So if we're going to have two ways to represent angles, namely degrees and radians, we need to be able to convert between the two quickly. Okay? So consider a circle with a central angle and a radius r. Okay? So a central angle of 1 revolution subtended an arc equal to the circumference of the circle. So what does that mean? I go all the way around 1 whole revolution. Okay? How far, what is my arc length all the way around, right? Okay, so because of the circumference of a circle of radius r, how do I find the circumference of a circle? Circumference, if you go back to your geometry days, is 2 pi r, right? So for a radius r. So S is equal to 2 pi r, right? So what's that telling me here? Well, if I have S equals r theta, okay, and I know that S is 2 pi r, then solving for theta gets me 2 pi. So what does that mean? There's 2 pi radians in a full revolution. So 1 revolution is equal to 2 pi radians. Pretty cool. Very important there. Okay, so we've just learned how to convert, right? So 1 revolution is 2 pi radians. So what does that mean? That tells me 360 degrees is equal to 2 pi radians. Now, dividing both sides by 2 tells me what? Tells me that 180 degrees is equal to pi radians. Okay. How's that any good for us? Well, if I divide both sides of the equation by 180, what do I get? I get 1 degree is equal to pi over 180 radians. Okay? If I divide both sides by pi, then what's going to happen? Okay? Well, if I do that, we'll get, if I do the reciprocal here and divide both sides by pi and multiply by 180, I'm going to get 180 over pi degrees equals 1 radian. Okay? So all I did was do the reciprocal, multiply both sides by the reciprocal. Reciprocal of pi over 180 is 180 over pi to get the other flip side. So why is this important? It gives us the 2 conversion formulas we need. Okay? So for 1 degree, this is pi over 180 radians. Okay? If I have 1 radian, then it's 180 over pi degrees. All right, so those, we'll get rid of the exclamation marks. So those are my 2 conversion factors, okay? The way I always remember what's what is if I'm trying to convert 2 radians, I'm going to have the pi on top. Okay, my radians are dealing with pi, and my degrees, typically I don't have the pi, I have the 180 on top. Okay, I associate 180 with my degrees, and I associate pi with my radians. That's how I think about it. How you memorize what's what, I don't care. You just make it work for you. So first thing I'm going to do is I'm going to convert from degrees to radians. Okay, convert from degrees to radians. So I'm going to have 60 degrees. We'll do 150 degrees. And I'm going to do negative 45 degrees. Okay, so how do I do this? All right, I want to convert 2 radians, so I know I'm going to be dealing with my pi. So I take 60, okay, 60 degrees, all right? And then what am I going to do? I'm going to multiply, all right? Now, what do I know? This is equal to 60 times 1 degree, okay? But I know 1 degree is equal to pi over 180 radians, all right? So I'll replace the 1 degree, which I had here, with pi over 180 radians. And when I multiply this out, I get 60 over 180 times pi. So 60 over 180, that's 1 over 3 pi. So that's pi over 3 radians. Okay, pi over 3 radians, all right? Now what about 150? I take 150 and I'm converting to radians, so I know I'm going to have pi over 180, okay? When I multiply through here, what do I get? So the degrees goes away, right? The pi takes care of that. I've got 150 over 180 pi. And so when this simplifies here, I'm going to get, let's see, I think this 30, right? So that's going to be 5, and that's going to be 6. So that's 5 pi over 6 radians. Okay? And now the last one, negative 45 degrees. Negative 45 degrees. Same deal, negative 45 times 1 degree. But I know 1 degree is equal to pi over 180 radians. And so when I multiply, I get negative 45 over 180 pi. And so negative 45 and 180, 45, not now. Come on, buddy. Divided by 180, 0.25, that's like 1/4, right? So that's negative 1/4 pi, which is negative pi over 4. Okay, radians. Cool. Now that we've converted from degrees to radians, we're masters at that. Let's go the opposite way. Okay, so let's convert from radians to degrees. Okay, so we're going from radians to degrees. So I'm going to start with pi over 6 radians. I'm going to do 3 pi over 2 radians. And I don't know, I mean, we could do 5 radians, whatever. Okay, and I'm going to convert this to degrees. Now, when I'm thinking degrees, I'm thinking 180. 180 degrees, that's what I'm thinking. 180 over pi. Okay, that's kind of how I think about it, all right? So pi over 6 radians. Now, this is 1 radian, right? Pi over 6 radians. Now, 1 radian is equal to what? It's equal to 180 over pi degrees, okay? So 180 over pi degrees. Now, what's going to happen with my pi's? The pi's here cancel, and I get 180 over 6 degrees, which is what? What is that? That's going to be 30 degrees right there. Okay. The next one, 3 pi over 2. If I'm going to convert it to degrees, I multiply by 180 over pi. Okay, when I multiply by 180 over pi, what do I get? Well, the pi's cancel again. Fight each other out. The 2 cancels with the 180, gets me 90. 90 times 3, that's 270 degrees, just like that. The last one is 5 radians. So 5 radians is equal to, 5, and then I'm going to convert to degrees, so that's multiply by 180 over pi. What do I get? I get 5 times 180, so 5 times 180, that's 900. Okay, over pi degrees. Now, I would be perfectly fine if you left it like this, but we can multiply that out because that's a little weird to look at. But 900 divided by pi, ooh, do I have a pi button? Yeah, okay. So divide that, I get 286.4788. So if I rounded to 2 decimal places, that'd be 286.48 degrees. Okay? All right. So there are some important degrees and radian conversions that really you ought to take the time to memorize. Okay? So if you don't memorize these numbers, then for the rest of the semester, it's really going to be challenging for you. So might as well put the work in now to get these memorized. And I promise you it's going to make life a little bit better. So I want you to memorize. Memorize. Okay, so I'm going to write the degrees versus the radian. Okay. All right, so 0 degrees is 0 radians. 30 degrees, this is pi over 6. 45 degrees, this is pi over 4. 60 degrees, this is pi over 3. I'm going to tell you, I teach Cal 1 and I teach Cal 2, and this stuff is used almost daily, at least once a week in both of those classes. So you really just got to go ahead and do the work now, get it memorized, okay? So 90 degrees is pi over 2. 120 degrees, this is 2 pi over 3. 135 degrees, this is going to be 3 pi over 4. 150 degrees, this is going to be 5 pi over 6. 180 degrees, this is going to be simply pi. Now let me do another one. All right, I'm just going to copy this. All right, so we're going to keep going. So 210, this is 7 pi over 6. 225, this is 5 pi over 4. 240, this is 4 pi over 3. 270, this is 3 pi over 2. 300, that's going to be 5 pi over 3. 330 is 11 pi over 6. And the last, 360, is a full revolution. That's 2 pi. Now, I know that looks like a whole lot, and we're going to go through something called the unit circle, and we're going to label each one of these on the unit circle, and hopefully when you see that, it will make a little bit more sense to you and be able to memorize that a little better. But if you can memorize it now, once you get there, it's going to make life just that